Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to do the second numerical which is based on percentage composition and molecular formula, as well as we are now including a new concept that you have already did, that is empirical formula. So let us do it. So friends, as mentioned on your screen, there's a question which is based on how to calculate the empirical formula, which is with the help of the percentage composition. So let us read the question itself. So the question reads out as: the phosphoric acid used in carbonated beverages contain 3.086% weight by weight of hydrogen and 31.61% of phosphorus, and the remaining part is of oxygen. So what we have to calculate is we have to calculate the empirical formula. So how can we do that? And as for the extra details are also been given, that is for atomic mass of hydrogen, phosphorus and oxygen. So in this case, the first thing that we are going to do is we should know the percentage composition of each and every element. Then only it will be very much good to calculate the empirical formula. So in this case, the hydrogen percentage is given, the phosphorus percentage is given, but the oxygen percentage is not given. But they have said it as the remaining part of the percentage will be of oxygen. So the first thing that we are going to do is we are going to find out what would be the percentage of oxygen which is present in this much quantity of hydrogen and phosphorus. So let us do it. So the percentage of oxygen which is present, how can we calculate? We could subtract it by 100. So suppose this is 100, that means the overall percentage of the compound minus the percentage that we have, that is for phosphorus we have, that is 31.61%, while that of the hydrogen we have 3.086%. So this is what we have, and now let's see what will be the answer for oxygen. So we have 65.304% of oxygen. So this is what we have got by calculating it. But this is not the work that is been done. We have to do an extra thing also. So what is that extra thing? Let us show you. So friends, this is a table that we have to draw. This is just for the convenience that how can we solve the numerical. So what I have divided is I have made a few columns in this thing where I have distributed in element form, I have distributed in by percentage by mass, I have distributed in moles of atom which is present, and the next thing is I have converted into atomic ratio, and the last one is simple ratio. It's a very simple kind of numerical, but the thing is it's very tedious to calculate, and this kind of table, it should be in our mind, and we should consider this table just for the convenience, and it would be very much easy to calculate. How? Let me show you. So first of all, let me give you the thing, that is how much elements are being present in phosphoric acid, as well as they have said that there is only hydrogen, phosphorus and oxygen. So randomly I could write it as any element here. So for first I could consider is for hydrogen. So suppose if I am considering hydrogen, then we know that the hydrogen percentage that is been given by a mass is nothing but 3.086. So if I calculate the mole of the atom, that is the mole of the hydrogen, and how can we calculate it? It is very much easy to calculate, that is mole means nothing but the weight divided by molecular weight of the atom. So the weight of the hydrogen is given as 3.086, while that of the atomic weight of hydrogen is nothing but 1. So the answer will be, that is 3.086 itself. And now talking about the atomic ratio, that how can we calculate? So in this case we have got a ratio as 3.086, but that is a very next concept that I am talking about. So now let us switch on to the next element, that is for phosphorus. So now the next one is for phosphorus. So the phosphorus has a percentage that is given to us as 31.61. So how can we calculate the mole of that particular atom or that particular element? It is very much easy. That is weight divided by molecular weight. So the weight that we have calculated right now is nothing but 31.16, or yes, 31.61, divided by the atomic weight of phosphorus, which is nothing but 31. So let us see what is the answer that we could get here. So we have got an answer as 1.01. Now for the moving to the last one, that is for the oxygen that is being present in this phosphoric acid. So we have calculated the percentage of oxygen as 65.304. So I could write it here itself. So 65.304 is the percentage, or is the mass of the oxygen. So I could write it as 65.304 divided by the atomic weight of the oxygen, which is nothing but 16. So what is the answer that we could get? We have got as 4.08. So this is the moles that we have calculated, and now what we are going to do is we have to calculate the atomic ratio. So how can we calculate the atomic ratio? So the rest part we could ignore, and the thing that we should consider the most is, in this thing we have got the values like 3.086, 1.01 and 4.08. So what is the smallest number among this? Yes, the smallest number among this is 1.01. So what we are going to do, we are going to divide this small number with each and every one. So let us see what is the answer that we could get. Suppose if we divide 3.086 with 1.01, so this will be the atomic ratio of hydrogen itself. So let me do that. So if I divide 3.086 with 1.01, this 1.01 is the smallest number among the mole of atoms. So the answer that I could get is 3.055. And now again for the hydrogen, that if we'll do the same thing. So again for hydrogen we have got 1.01, but the smallest number is again 1.01 itself. So therefore 1.01 divided by 1.01 will be nothing but 1. And now talking about the last one, that is for phosphorus, for oxygen atom. So in this case, this 4.08 should be divided by the small number, and again the small number is 1.01. So if I divide 4.08 divided by 1.01, then let's see what is the answer. So we have got it as 4.03. So this is the atomic ratio that we have got. So how can we convert into a simple ratio? And again, as we could say, that this number is not a very large number that we could convert, that is, this 3 cannot be converted into 4. Why? Because the decimal is 3.055. So therefore we could consider this thing as 3 itself. We could consider the 1 here as 1, as well as the 4.03 as 4. So therefore this is the simplest ratio that we have calculated here. So this was the table, and from there we have calculated the simplest ratio. And what is empirical formula actually? Empirical formula is the constituent of the particular atoms that is present in a molecule, but in a simple ratio. So therefore this is how we have calculated that the hydrogen is of quantity 3, while phosphorus is of 1, and again oxygen is of 4. So therefore the last statement is the empirical formula for phosphoric acid is nothing but 3 times of hydrogen, that is H3, that is 1 times of phosphorus, that is P, and 4 times of oxygen, that is H3PO4. So this is how we have calculated the empirical formula using the table also, as well as using the help of percentage composition. It is very much easy. So I hope you will do this kind of numerical in your future also. So thank you friends for watching this video. I hope you have liked this video and you have understood this kind of concept. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.